Welcome back to online lab number 3. This is part 2, where we are going to examine together what happens with sports drinks. Now, I didn't have any Gatorade on hand, but I've done this before with Gatorade and Powerade, and they're really pretty much the same. I had some soda, some root beer in my refrigerator that my kids had drunk, and I was curious to see what kind of conductivity that we're going to get from that. And I expect some differences. All right, now you can see here that I have again my my beaker, and I thought people might be interested in seeing. Oh, there it is. This is the stir bar. Okay, and over here I have my my solutions. Now I've done this before, and there's not a lot of sodium or electrolytes in the Powerade, not compared to other things. Okay, so let's go ahead, and I'm going to, over here I have, this is from part 1, so I'm going to go ahead and we'll just store it, and we'll call this run 3. Okay, so here I am. I've got fresh, clean everything, so my my values are a little lower here. I'll go keep, and this is the 0 point, and this first run is going to be the root beer. And I'm very curious. I've never done this. We're both learning right now, which is kind of exciting. And I put a drop in there. Very interesting. Nothing. Maybe, well, maybe a tiny bit. Let's see. We'll go ahead and keep going. Okay. Interesting. So you can see here that we're not seeing any increase really at all. I'm gonna, yeah, we'll keep going with this though. This is our experiment. So very slow increases. And again, this is very, very diluted. Remember that. This doesn't mean that there's no sodium in your beverage. It just means that there's very little. And right now we're not comparing this. Don't plot this on the same graph as your sodium chloride and your calcium chloride, because you won't see anything. You need to actually show another one for this. Okay. Okay, so it's very interesting here. We're not seeing a little bit, but so this is only 2 significant figures here, but we are seeing a line here. And I think that really what that means is that we are seeing an increase. It's just not showing up in the significant figures. I think that was number 5. Okay. So yeah, interestingly enough, we are seeing a very, very slight increase. And I mean, 1 molar solutions are pretty high. It's, all right. 6. we are seeing a slight increase there. Whoops. And we'll do one more so that we have that 8. Okay, and we'll go ahead and stop that one. And now what I'm doing is I'm just switching things over. If I was in the lab, I definitely wouldn't be fishing out my stir bar with my hands. I'm clearly not working with anything dangerous today. If you're curious, I mean, this is just drops of root beer, drops of Powerade. Yeah, the salt water was just a 1 molar NaCl solution, and the calcium chloride is just ice melt. I wouldn't do anything, you know, harmful or bad for the environment in my house. All right, there we go. Okay, so I'm just moving this over and using that solution to clean my pipette. Okay. And so again, I'm going to choose Start and Store. And now I'm up to run 4, which is my Powerade. Okay, so I'll go ahead and keep my 0 point. And then we will try this with a sports drink, a true sports drink. Okay. So that was 1 drop. Whoa. The reason sometimes it goes up and then comes back down again is that in the mixing process, sometimes you'll get a little bit of dissociation and then it moves. Okay. So this one is definitely increasing faster than the root beer was. That was drop 3. And drop number 4. And 5. I'm seeing a very interesting, not quite straight line curve there, which probably means that my drops were a little off, or maybe I rushed the count a little bit at the beginning. drop 6. And there's drop 7. And we'll do one more so that we have our full 8 for each one. And there is drop 8 for that as well. Okay. So now let's go ahead and look up our data. Yeah, you can kind of see this is what happens when we plot them all. Okay. We've got run 3 and run 4. That's very interesting. So you can almost see an exponential curve there. It'll be interesting to see how that works. Even though it looks a little bit like that, we want to go ahead and do these with linear regressions. Okay, so let's go ahead and take a look at our data for these. And all right, here we are on run 3. Okay, and as we fill in here for the root beer, we can see that we'll have a 78. And you know what I'm going to do? Because these are so low, I'm going to look here at conductivity, and it tells us decimal places, displayed precision in our decimal places, and I'm going to tell it 2. I want to see, there we go. Now we see a little bit more variation. Okay, so we got 78.47 for our 0. And then our 1 is 78.69. And then 79.31. And 80.08. And 80.60. And 81.05. Sorry about that. Goodness gracious. There we go. An eraser. 81.64 and 81.98 and then 82.22. So there's definitely some electrolytes in that one, and it's just not very much. Now on the same graph as the root beer, you're going to plot the Powerade. Okay. And there's our run 4. And so our 0 point for this one is 68.58. And 1 drop is 70.13. 71.68, 74.72, 78.15, 82.73, 88.10, 93.92, and 98.70. Okay, so let me go ahead and show you these. so that you can compare what you've written down. Okay, so then looking just over this, remember you're going to create 2 Excel charts, one for the sodium chloride and calcium chloride and one for the sports drinks, and add a trend line to each one. Okay, and then Excel is here, and that's part of that Microsoft Office suite. But if you don't have Excel, or you don't have a good version of Excel, you can use Google Sheets or any other spreadsheet program, as long as you can apply a trend line, and you need to make sure you display the equation for that trend line. I'll be making a video about how to do that in Google Sheets that hopefully will be helpful. And then remember to compare and contrast the trend lines and equations for the 4 solutions. Let me know if you have any questions.